Live from Twitch TV, and we are back. And let's get straight to it. We're just going to continue on from what we had yesterday. So what that is, we just run a test, and we run our front-end tests, and then they meet up in the middle, and they run their integration together, and you'll see that they passed. So let's continue on. So we've got write unsigned byte to socket. We've got write integer to socket. Let's go on to should write unsigned integer to socket. This one's going to be slightly different, such that we unsigned integer that we don't get negatives for one. So write uint. In fact, we should probably persist that across the interface. Right, unsigned int. Oops. So that the compiler will even stop us from doing it, and that's a good thing. So, right, unsigned int should be a uint. And this should be a write uint 32. This way, we can take care of some compiler funness. Uint. Okay, and now let's see here. So this doesn't even work. Definitely get 0. Basically, this times 2. Which we could probably do the math for. Times 2, which is that. Wonder if there's a integer uint. No. Seeing if there's like some sort of max now. No. That would have been kind of cool. But not available apparently. Maybe someplace, but let's do that. Okay, so we should be able to run this, and it should. Okay, so looks like hex IO up. It has no field uint 32. So it looks like it only does 24, which is a little odd. And that should build. Okay, so it looks like we're over by 1 likely. So it should be uint. It's probably a 24-bit int. So let's look up what's going on here. Hex uint max size. What's going on here? Uint. Doesn't really give us any details there, and it gives us int. There. Let's take a look at math, see if there's anything in here. Negative infinity, positive infinity. Nope. Let's do a dual. Wait a minute, what's this up here? CPP uint 32. There we go. So that'll break interface compatibility, and I don't like that. It's only available in CPP. Let's take a look at the sysnet socket. There's the output. write uint24. X is a 24-bit unsigned integer. 24-bit unsigned integer max size. And looks like it's this. So this is unsigned. Alright, so that'll get some of the stuff off the socket. So it looks like there's some sort of issue here. Okay, so first of all, our CPB input output stream test, this needs to go to, okay, oh, this is the test, write uint 24, okay. And it looks like this is probably because it's not connecting. So let's do our Elixir side. AVI lib game server, I don't know, test game server integration net socket read integration test. In fact, we should move that now. Test game server integration net socket read, and this is going to just move to test game server integration socket integration test, and we'll just do the whole thing there. All right, vi test game server integration net socket integration test. Okay, so now we're going to move up to test number 4, and what we're going to do is we're going to fp run test unsigned integer okay, and client number of tests left do, okay, and then we need to assert these things. So let's do a handful of these. I think there's only 4 of them. That was 3. So we're going to do here, and it's going to be this, this. Which doesn't seem to be a good reason to do an unsigned int if it's only 24 bits. Because the regular integer is 32 bits. So it seems a little odd. I wonder, it seems really odd that it would actually so that actually builds. I wonder if it just takes int. I bet it does. So it's a little janky in that respect. I wonder why that's missing. Seems like a real miss on that one. Let's go back to the output. Seems wrong. It just doesn't feel right because we have int32 and we have uint. We just don't have a uint32. This seems odd. So it's better just to use int. So what I'm going to do, I'm going to just straight up abandon the unsigned int because it's just not as good. So we're just going to do here, I'm going to cut this out. This is not implemented. And let's just update our tests because it's not really beneficial. I'm going to cut that out as well. We're going to ditch this, and we're going to go to the CPP socket batch and the CPP socket test, and we're just going to take this test out altogether. Doesn't make sense that we have our unsigned int not as flexible as our int. It just seems ridiculous. So test should write float to socket. Prepend test type is going to be float. Stream write float value is going to be, first of all, we want 0. We want some decimals. We want some plus with decimals, and then we want some negative with decimals. And that should do the trick. Here, this is going to be a float. And we're just going to grab these few. Make sure we grab this. That's important. Okay, so we got 4 assertions. Which one is? One is 0. It's just a hair off to the side. Okay, let's see here. 0, 0.432, and that one. So next test, and let's do this. So that one has failed. Okay, and this passed. Okay, so that's good. So the right float, looks like there's an issue writing the float. Okay, so I think we're probably, let's run this test again. Let's see here. I think we probably need to go with, what is the float on this? AX. Erlang binary to term to binary. So it gives us 8. So it's going to give us a double no matter what. Okay, so we need to write this over that. And let's see about that. Argument error. Two, 3, 4, 5, 6, 7, 8. Okay. 131, 110. Oh, I think what we need to do, I think we need to, yeah, we need to work with this specifically. So def p receive client length. Is float? That's the question. Oops. Elixir is float. Looks like there is. When length. That's not going to do us any good, is it? So we're going to do, and we're going to receive float. float, float, float. Okay. Client, stream, receive length, then to value, get float. So and okay, let's see what's going on here. We're getting 5 to 1 crazy. Okay, so I'm expected 0. So let's take a look. Let's take a look here. Better not be Indian this. I thought we set that here. Yeah, we did. Okay. Let's take a look. I wonder if it's because it's 0. Inspect. Let's see what's happening here. So we're getting 1, 2, 3, 4, 5, 6, 7, 8 bytes. And what we need to do is we need to do our bin to value. Bin to, no, darn it. I have to do this first. Thanks. There we go. Bin to value, get float. Really? Why is it not available? Oh, because it's game server util. So that is definitely a weird number. The thing is, I think as far as our test is concerned, we should be getting 0. So let's take this out of the mix for the moment and figure out if that's the case. Okay. So that is also a strange number. Zero should not have anything. It should be a bunch of zeros. So why is this writing funny? Write float. Okay, so let's just write a 0. Seems a lot more reassuring. Our test, just want to make sure this is all correct here. And we're getting a very strange thing. Wonder why. So what I'm going to do, I wonder if this, I wonder if we have, no, that wouldn't make sense. Let's see here. We're going to cut out most of this. And I think we have our server. We're just going to do this here. So socket TCP listen to 1237. Oops. Client equals socket TCP accept. Server. Okay, and then we're just going to run this real quick and see what's going on here. So we're going to do client socket TCP receive H. Well, actually, 1. Stream 1. If I just do receive. Okay. All right. Let's try this again. So the first thing we need to do is we need to receive 4, which will give us the length, which is 5. Okay. So then we need to receive 5 bytes, which is our float, and then we're going to receive 8. Just nothing. I wonder if it's because we're not doing this. Okay, so let's try that. Wonder if it's not actually sending 0. So let's receive our 4, our 5, and our 8. No. Okay. Let's try that. This is very, very strange. So 5, there's our float, nil. Is this not working? Right, float. If Flash, not Flash or Python, inline it. Float to I32. That seems wrong. Because that'll convert to an int. Right, int 32. That'll convert to an int. That's not correct. So what we're going to do is, in our implementation, we're actually going to write double. And see if we get a better result. So we're going to receive our 4 bytes, then our 5 bytes to know it's a float, and then our 8 bytes. There it is. Okay, and then if we receive 1, this will be nil. So there it is. It's some strange way of doing float, and I don't like it. So we're going to stay away from it. So we don't need this open. Where's our net at? It's integration net. So write float should write double. Okay. And now we can do this correctly. Let's go back to our integration test. And let's set it back up. So now let's test address already in use because that's running. And let's see what happens here. Okay. We needed a that. Left hand side is 0, right hand side is that. So we got 0 twice. It appears that it should have just been 0. Left hand side is 0. Left hand side is 0. Alright, let's just run her again. Okay, still strange. So the data it came across was zeros. Seems like it should be correct. And this is on line 58. Doesn't make sense because we should get 2 sets of this then, and we didn't. We only got 1, which would be this one. That means this one was weird. This is weird. It's behaving like it's multi-processing. Weird. Okay. I don't like it when things are weird. So that one succeeded, and it did give us our 8 bytes. If we need this, we need this. It's only printing 1 set of these bytes. Wait a minute. That succeeded? I think 1, 2, 3, 4. 1, 2, 3, 4. It is 4. Argument error. So that's what's is blowing my mind right now. I'm guessing it wasn't saved. No, stop that. I'm guessing it wasn't saved, and when it was, it's the only thing I can think of. It wasn't saved. But now it's working. Now it's a success. All right, so I'm gonna go with the idea that it probably wasn't saved, which is sort of a bummer. Okay, let's do this again. Write a double to the socket. Which is essentially the same thing as we just did. We'll just add some bigger numbers to it. Oops. Okay, 5. And I'm just gonna grab this, I think. Put space there. Double. Whoa. Okay. Let's do this. There we go. All right, what do we have left? Let's go to our stream. We've got write double, write unsigned byte. I think that's our last. Do we do unsigned byte? I think we did unsigned byte. Unsigned byte is in there. Float int short, which we're not fully sure is going to work. Based on what we've seen so far, this write short may not happen. Test should write short to sockets. That's probably unnecessary, but let's do short write short. It's just 2 bytes. So okay, and we're just gonna make this, put it there, put it there. Now we need to do 438. Man, it's been a typing day. 438 negative 315 0 So line 56 always matches 47. Oh. Short. And we need to increment our number of tests, which is 6, right? 1, 2, 3, 4, 5, 6. And we have a overflow. I think we actually want to do write 16 on this. Alright. So, it is what I thought it was going to be, so let's just double check. What's going on here? IO inspect. Let's see what's happening here. We're going to ignore all these guys. Actually, no. Okay. Those are going to be fine. What we need to do is we need to do inspect short. Okay. No one fails because of this here. So on the right page, we're going to write int 16. Okay. So short is this guy. And I don't think we want to be writing, I think we actually just want 2. Let's do this. So here, what we're going to do is we're going to Erlang binary to list, this to make that a list. Then we're going to add 2 zeros on it. Let's do this quickly, and then we're going to do game server util bin to value, and we're going to do the list Erlang list to binary. Get value 438, and that's what we want. Is it? I forgot. Yeah, 438. So that's what it is. So it comes across as 2 bytes, but we can actually convert it that we know of. So that I know of, anyways. Okay, so let's do this. We're going to do vi and actually have this method in my library called pad list, and we could just use this because we're going to end up using this anyways. I'm pretty sure I will because it's already ready to go. It's set, it's tested. So what we're going to do is, first of all, this is private and that's not going to work for us. So I'm going to steal it from myself for now. No, I'm not going to steal it. What do I want to do about this? Let's do this. Get clone patch it. vi lib, oops, here. This is going to be IO buffer, vi lib value converter, and we're going to make this public and at doc adds zeros to pad the length of the array to make it the necessary size. Examples. IEX here, value converter, pad list, and we're going to give it this and that, and we're going to say 4, and this will give us a list like this. Do those spaces? No, I don't have spaces. Like this, 32, 58, and we'll do another example. This is doc testing, by the way. And we're going to pad this so that our documentation stays up to date. So we're going to do 9, and this is going to be padded with 8. And so this will give us 0, 2, 3, 4, 5, 6, 7, 8. Just like that. So now, mix test. Return on is declared. Oh, okay, so we're going to do that. And did I type it wrong? I did. Look at that, beautiful, 34 tests. Git status, git commit, updated value converter to make pad list public. Git push origin master. So that's patched. And now we can go to our mix file, and we're going to do IO buffer, say git, git, depths.get. There we go. And now we should be able to use the value converter pad list. So just going to run back over here, and it is just a bunch of value converters. So what we're going to do is when we receive the short, receive 2, we're going to ft receive client to do client stream receive to value converter. No, that won't work. Bin to value, get value. Okay, so now vi test game server util. Let's see this right here. Test should convert 2 bytes into a value. Do end assert in to value, get value. We're going to do 0, 4 is equal to 4. What if we do this? 4, 0, oops. 0 should be 1024. Okay. Now, let's see here. We do mix test game server util, and there it goes. It gives us nil. Vi lib game server util value, and if byte size is 2, we're going to take the binary Erlang binary to list value converter pad list to 4, and now we're going to go to, we could probably just do this here. Let's make this dry Erlang list to binary get value, like that. Mix test game server util. Here we go. There we have it. Now we should be able to run this, this, that passes, and this one fails. Darn it. Negative 315. So the first one passed. I'm curious to see how this came across. IO inspect. Okay. Just curious. IO inspect short. The 2, we're going to do IO inspect. So now it gave us that number. I wonder if it's because it's a negative. Do we have a unsigned short? Unsigned short. We have a read unsigned short. Thinking. Server equals socket TCP listen, and then client equals server socket TCP accept. Okay, what we're going to do is we're going to just narrow this down. Once again, find out what's going on. All right, so we have this in here, so we're going to say client socket string receive 4. This will tell us the number of bytes for the thing, and then we'll do 5, which would print out short. Then we receive 2, which is our 438. And then I wonder if we do receive 4. Is that going to be our negative? And then do the rest. Is there anything left? Okay, so is this our problem? Bin server util bin to value get value. Oh, where do you got that there? No. 315. Oh, you know what it is? It's probably this. That's still not the right number. Right short goes to right uint, right in 16. Why is this such a strange number? Essentially it's this. Maybe we can't do write short. We have to just write unsigned short. We can't do with negatives. I don't like either one of those options, so I'm going to give it some thought. Trying to think what would make this a negative number. So let's find out what this could be. Negative 315. Everything. Term to binary. So that's what's going on. When it's negative, so there's no really way to know that. That's a bummer. So we can't handle that. Thinking. Okay, so we cannot handle. It's strange we don't have an unsigned short. do this. Right, unsigned short. And then you get unsigned shorts. Or we just convert it to an int. That defeats the purpose though. We want 2 bytes. If we can help it. Less data the better in that sort of control realm. I'm gonna go with this for now until I think about this a little bit. Unsigned short. Right. Unsigned short. This doesn't exist. Think about that one. Oops, might keep that one. Okay. This may not even build. Looks like our right. And 16 in the right, unsigned short. And this failed because we're not actually running all our tests. So let's get this back in gear. And let's run this, and we should have this underway. So that passed. We can get rid of one of our inspections here. So we have 1, 2, 4. And it looks like we're going to have quite a bit in place. There's a couple of things I'm not super duper timey-wimey excited about. But I'll have to give some thought about that short business. There's no way to know that it's going to be positive or negative based on the data received. And not sure why that is. So we're going to just stick with that. And let's do it. So let's get this committed. Git add test game server status. Git commit finished tests for reading, finished integration test for reading from socket. Git, right? Don't have that set up. So git status, git add sources, git add test, git commit, finished integration test for writing to socket. Alright, so what we're going to need to do is tomorrow we're going to do the opposite. We're going to start reading from the socket, and then we're going to have an integration where it's writing to the socket. So we're going to tag this with 2016 Cinco de Mayo. and this is going to be 0859. Push. So happy Cinco de Mayo, everybody, and I'll see you guys tomorrow. Have a great rest of your day.